All right, today we are going to look at symmetry, and we're going to look at two different kinds. I think you're probably familiar with line symmetry. Line symmetry is when you can draw a line through a figure and it looks exactly the same on both sides, almost like makes like a butterfly figure. So if I have this square here, I could draw a line of symmetry down the middle because it would look the same on both sides. I could also draw a line of symmetry across the center, couldn't I? Makes it look like it's exactly the same top to bottom. Are there any other lines of symmetry? Okay, your diagonals. Now, is that going to work in a square or rectangle? Excuse me. No, your diagonals don't work in a rectangle, so just be very careful. If you're taking this like on an assessment or something and you really want to be sure or be certain about it, you could trace this figure on a piece of paper. Draw where you think the line of symmetry is going to be and then actually folding the paper and see if you can kind of see through it to see if it matches up exactly. If it does, then that is a correct line of symmetry. So we can say that in this case, this square has 4 lines of symmetry. You can do it with capital letters or just about anything. Let's say I have a capital letter H. And we're going to check to see if it has line symmetry. Would it have any line symmetry? Okay, I think that's a perfect H. Where would it be? Would you have one going across the diagonals? No, because see, if you draw a line there, it's not going to be exactly the same. Where would they be? Up and down in the center, that would be one line of symmetry, and across the center. Okay, so this one would have 2 lines of symmetry. Thumbs up if you're okay on line symmetry. All right, good. Now we're going to look at rotational symmetry. Rotational symmetry may not have been introduced to, but it's when you can actually rotate a figure. So if I want to find out if this square has rotational symmetry, I hold it down in the center and then turn it around and see when is it going to look exactly like its original position. How many degrees you're going to turn it. Or kind of like what we were doing the other day with the tick marks when we were just doing a rotation. We're going to kind of do something similar to that. Now I have a site here we're going to go to that is going to help us see this just a little better. Okay? This shows rotational symmetry. Now you can do rotational symmetry 2 different ways. You can do it by order or you can do it by degrees. Now this figure right here has an order of 2. In other words, it's going to click into the same position twice in 1 360. Now you see where they have their little mark? So we're going to keep track. Help me. Count along with me when it hits the same figure. 1, 2. Okay, so that's why it has an order of 2 for rotational symmetry. Now if I'm saying degrees, how many degrees is that rotational symmetry? Well, we always go 360, but how many times did it repeat during that time? Twice, so then 360 divided by 2 is 180. Or watch where this dial is. It'll be clear at the bottom or at 180 degrees from where it started when it first hits. Ready? Boom. So see, remember it's 180 degrees. So we can say that this has an order of 2 or a rotational symmetry of 180 degrees. All right, let's take a look at this figure. 2, 3. Very good. 1, 2, 3. So it has an order of 3, or how many degrees would that be? How'd you get 120? Okay, you took 360 and I'm dividing by 3 because I do it 3 times. That'll hit that same picture. Well, here's an example then of some orders. So rotational symmetry is based on the orders, and that's kind of like how many, I call them fingers, or like you have a star. And this one, these are fans. How many blades do you have? An order of 3 kind of has 3 blades. An order of 4 has 4 blades. This is an order of 8. Could you have an order of 5 and 6 and so forth? Yes, you sure could. Is there a rotational symmetry of order 1? What do you think? No, because if it takes a whole 360 to get back, then it doesn't have rotational symmetry. Make sense? Because if it takes a 360 to get back to what it looks like originally, then we say it does not have rotational symmetry at all. Okay, here's some other examples. This has rotational symmetry. My goodness, let's see, 1, 2, 3, 4, 5, 5 at least that you could rotate it. Does this have rotational symmetry? Oh, it looks like they said order of 10 here. Okay, this has an order of 5. And this one, whew, too many, I lost count. Any questions on rotational symmetry? So in rotational symmetry, you keep track of the angles of rotation. So let's do this. Let's do an equilateral triangle. Draw that in your notes. And they all have the same angle measurement. Now, what order would this be? This would be an order of what? Remember, I started here. How many? 3. Okay, so it's an order of 3. Or how could I state it in degrees? 120 degrees. Because you took 360 divided by 3. That's how you got it. All right, any questions on rotational symmetry? All right, that concludes our lesson today.